So now we're going to take a look at the graph of the cosine function. So the graph of y equals cosine x. So here we need to be careful what x means because, again, I'll remind you, x, when we're doing these graphs, is the same as an angle in radians. So we're thinking about x the same way we thought about theta before in the unit circle. Now the y, so the y coordinate of our graph, is the cosine of that angle. So this is what we used to call x when we were doing the unit circle. So please just be aware of that because that's really easy to get confused, that now x is always going to be an angle and then y is going to be a trig value of that angle. So either a sine, a cosine, or a tangent. So let's go ahead and work through this the same way we work through the sine function. So we can start by looking at our nice multiples of pi over 2. So if we start at x equals 0, an angle of 0 has a cosine value of 1. Pi over 2 has a cosine value of 0. Pi has a cosine value of negative 1. 3 pi over 2 has a cosine value of 0. 2 pi has a cosine value of 1. And then if we wanted to keep this going, 5 pi over 2 is coterminal with pi over 2, so the cosine is 0. 3 pi is coterminal with pi, so the cosine value is negative 1. Negative pi over 2 is coterminal with 3 pi over 2, so the cosine is 0. And negative pi is coterminal with pi, so the cosine value is negative 1. Okay, so once again, we can connect our dots. And we're going to get a graph that looks something like this. Change the point where that turns around, because that should turn around exactly at our dot. Okay, so you'll notice first that this graph looks a heck of a lot like the sine graph. The sine and cosine functions actually have a lot of similarities. That is due in part to that cofunction identity, that there is this relationship between sine and cosine where we can get the graph of one by shifting the graph of the other. So that is really important to keep in mind. Now, because of that, sine and cosine are going to have the same domain and the same range. Okay, so the domain is still going to be all real numbers. So if we write that using interval notation, that's minus infinity to infinity. The range is negative 1 to 1. If we look at the intercepts, we see that we have x-intercepts now at all the odd multiples of pi over 2. Okay, these are all the angles that lie on the unit circle along the y-axis. So these are all the angles that are coterminal with pi over 2 or 3 pi over 2. We're going to have our maxima. So we call these relative maxima, the tops of our hills, at angles that are coterminal with 0, because that's where our cosine value is at its maximum. Cosine is equal to 1. We're going to have the bottoms of our hills, the relative minima, at all the places where the cosine is negative 1. Okay, so those are going to be at all the angles that are coterminal with pi. So pi, 3 pi, minus pi, and so on. We see that we have a y-intercept at y equals 1. Okay. And just like with the graph of the sine function, we're periodic. Okay, our cosine values repeat every 2 pi units. Okay, so now we have this piece of our graph where if we start at 0, we would go down and then back up. if we were to copy and paste that over and over and over again, we would get the entire graph. So we still have a period of 2 pi. We still have this repeating graph, and we still have this wave behavior that goes, up 1, back down to the x-axis, down 1, back up to the x-axis. So we have this amplitude of 1. Right, so that is the fundamental graph of the cosine function. Now what we're going to do next is look at the graph of sine and cosine and look at some ways that we can manipulate those functions and in turn manipulate our graphs.